It's not working in prod. Indeed, it's not working in prod. Well, it's not my problem. It works just fine on my machine and on the dev server. Well,
I told you all systems are ISOs. And if it's working in dev, it's working in prod.
it's ISO?
Oh yeah, essentially, I mean, pretty much almost.
Almost? What do you mean, almost?
You know, there's maybe a very small gap in minor versions, and for some plugins. Nothing particularly important.
Hello, everybody. Thank you for joining. Yeah, it looks like we have some folks on there watching already. Yeah, I'm excited too. All right. Well, today I'm going to be talking about how to containerize your React application. So mostly we talk about Node.js and containerizing middle tier applications, but a lot of times we don't talk about how to containerize your front end application. And it's actually pretty easy. It's pretty straightforward. So we're going to walk through starting from the very beginning, creating our Docker file and walking all the way down to creating a image that you can use locally to develop, and then also how to productionize that. So adding NGINX to the front end as a web server. Yeah, so let's jump right in. Okay, let me share my screen. And go ahead, if anybody has any questions while I'm going along, feel free to put it in the chat there, and I will get to them for sure. Let me just get things set up here. How's everybody doing out there on this fine Thursday morning, afternoon, evening, depending on where you're at in the world? All right. Whoop. You heard my voice there. Okay, sorry about that. Let's go ahead and share my screen. Let me move out of the way. Okay, let's make that a little bit bigger. Bump that up nice and big. There we go. Okay, so I have basically a test little application, little sample application that I wrote. That I use this kind of framework a lot for just showing some demos, but it is a React application front end. It's based off the Create React app. I like to use Create React app because it's known pretty well out there in the world. So let's jump over. Here's the code base. Should be pretty familiar if you're a React developer. So we have this index.js that kind of sets everything up. We have one component called app that is right here. And it basically builds out, skipping down to the render method. Sorry for the fast scrolling there. So you can see we're dumping out a bunch of HTML. We have a little form at the top. You can create new records. That's here. And then we show a list of records that we're creating at the bottom. We have some loading and results. So let me demo the app real quick. So I'm sitting right here. I'm just going to do an npm start. I'll let that fire up. And I'll pull up my trusty Brave browser. And there we go. So the application's running. Let's make that a tiny bit bigger. Not too worried if you can see the demo app running. It's not that exciting, to be honest with you, but it does its job. So let's create a new record. I'm going to call it name, and we'll do foo, my infamous foo. Let's save that. Oh, got to give it a entity name at the top. And these are all going to be foos. So let's save. You can see down here at the bottom, we have a foo. Let's get a bar in there. And we need a baz. All right. You can see I created a couple of records. This is all just, again, just a test app. Nothing is being saved into a database. I'm just saving it into memory for demonstration purposes. Okay. So we have an app running just like you would normally. We have Create React app running in the background. We just have an npm start that sets up your local dev server. We'll watch your file system and just keep restarting the application every time you make a change. Actually, let's just show that real quick. Let me restart it here. Back into the app. Fresh. Over the code base. Let's find the submit button right here. You can see right here, that's the submit button. That's this button. And let's make it say go. Let's save that. Boom. There we go. Just as normal, you run and create a create React application. It has a little dev server. It's watching our code. It's refreshing. You do this all the time. If we needed to go in and set a breakpoint, so let's handle the submit. I'll just put a breakpoint right here. I'll come back, click on go, and there we go. You can see I'm able to debug. Everything's normal, working the way you usually would. So let's take off our breakpoint. Okay. So let's talk about, let's change this back. Let's talk about how you Dockerize an application. So the first thing we want to do is we need to create a Docker file. So I'm going to do this just as a side note. You can see I'm using VS Code. VS Code has a lot of plugins. There's a Docker plugin. You can actually use the plugin to create a Docker file for you, a compose file, all those type of things. But as we're learning, I would like to do it manually so everybody can see the steps I go through and my thought process behind that. So first thing we want to do is let's shut this down. I'm going to do a, do a Docker file. So I'm going to create a Docker file. Now we have our Docker file. Okay, so normally when you start working on a team or you're working on a project, you would pull the code down from, let's say, GitHub, from a Git repository. Let me take a look at, see if we have any questions or anything. Sorry, my screen is a little bit small here. Okay. Yeah, so Raphael asks, tell us a little bit about, let me hit that button. Tell us a little bit about Docker before we get started, just in general, so I can bring everybody up to speed. Great question. Sometimes I assume that folks know what Docker is and don't talk about it. So yeah, so what Docker is a way that you can containerize your applications and then run those applications anywhere that you have a container runtime, a Docker engine, Kubernetes, EKS, ACI, which is Azure Container Instances, ECS, Elastic Container Services, anywhere that can run a container, a standardized container, you'll be able to run your application. So what a Docker, what a container is a running instance of a image. And what an image is a collection of all your source code, compiled code, not necessarily source code, forgive me, thinking in the JavaScript world where it's not compiled. So if you're in a compiled language like C, it would be your executable file, all your configuration files, all its support libraries, operating system support libraries, anything you need to run that application, you can put inside of an image. And then once you have an image, you can run that image inside of a container. And what a container is it takes your process, a normal operating system process, so a normal Linux process, the same as if you would run a process in your terminal, takes that process and it isolates it from the rest of the system. So it restricts access to the different files, to networking. You can even restrict to how much CPU usage, how much memory usage, network access, all those type of things. But at the base of it, a container is nothing more than a normal operating system process, but it has been isolated from the rest of the system. An image is where a lot of the power happens. These two things combine together. But an image is everything zipped up basically in a tar file. So all those files, configurations, EXEs, everything you need to run your application is put into an image, a package, then it has some metadata on it. So then when you go to run that image inside of a container, it knows how to run it and the different things like that, how it should be configured. And so it packages all that up in an image, and then you can share that image around. So you can push it up into Docker Hub. You can pull it down from Docker Hub. You can run it in AWS, in Azure, GCP, in your internal own cloud. You can share that with fellow developers. As long as you have the Docker engine running, you can run that image. Okay, hopefully that was clear enough. If you have any questions, go ahead and ask me in the chat and I'll try and get to them. All right, awesome. So to be able to create a container, which is an image running inside of an isolated, it's a process running isolated on the system, you have to create an image. So to create an image, you start with a Docker file. And basically a Docker file is a list of commands that you would normally run to install your application, to get all of its configuration there, and to actually execute it. So let's take the scenario that I have a server running somewhere. Maybe it's an EC2 instance. Maybe it's just a VM in my internal cloud at my company, and I need to run my application there. So before containers, you used to SSH into that server, make sure you would get the operating system installed. You would set up the VM. You'd set up the VM, get the operating system installed. Then you would SSH into that VM, and you would install, let's say, Node, the Go runtime, the Java runtime, the .NET runtime. Then you would get your application code in there, all of its configuration, and then you would run your application, right? And you can automate that through scripts, but that doesn't scale very well, right? You have to point it to each server, make sure you run the exact same script with all the setup. You could even script how you run that script on different servers, but it becomes complicated. And there's different ways that different tools out there that can handle that. But at the base of it, it's a lot of manual updating. And you also have to worry about the server, all of its security patches, all those type of things. But now that we use containers, and by the way, container technology has been around for a long time. Docker didn't invent container technology. What Docker did was made it very, very simple to use those operating system constructs that allow you to containerize an application, containerize a process. So like all great technologies, I know I've said this on the show before, they level up the abstraction. So it allows you to work at a higher level of abstraction that's a lot easier for you to reason about, right? If every time we had to create an isolated process on a system, on a server in the cloud, we had to be C developers and go write C code and spawn processes and give it the correct permissions and restrictions, that's a pain, right? That's hard to do. It's not scalable. So Docker came along and wrapped the Docker engine around all of that and allows you to do that with a couple simple commands. Okay, so let me take that question off of there. Okay, so jumping back a little bit, to be able to create an image, we need to create a Docker file, which again is a list of commands that produce an image. And those commands are going to be very, very similar to what you would do if you scripted out, let's say, a bash script that you would run on a server to install your application. And so the first thing we want to do is you typically don't start out with a base, with a blank image, right? We have what's called base images. So Docker images, you can kind of stack on top of each other. You can kind of think of it in object-oriented terminology, right? So we're going to use inheritance. We're going to use a base image and we're going to inherit from it, and we're going to create our image on top of that. Right. So it would be the same thing if I had, let's say, a person class, and then I wanted a user class that had, so the person class had first name, last name, phone number, and a user then has a username and password, but it also has a first name and last name. So we want to use that functionality, that base class. And so we extend it and we add some more functionality onto it. So that's what we're going to do with the base image. So we're going to take a base image and we're going to use the node base image for now. Let me get the exact version I want to do. Well, let me walk you through the process, how I think about grabbing a base image. So the command you use is called from. So from will pull down from Docker Hub that image, put it into your image, and then build on top of it. So I'm going to use the node 14.17.3. And where do I get this number from? What is this here? So this is the a full reference to an image name. And where our images live, they live on Docker Hub. So let's go in there. So I'm going to go to hub.docker.com. I can come to the search box. I can type in, not hub, I can type in node. Our search engine goes out. We see that we have a node image here. Now, how do I know this is a good image that I should use? Well, we can see over to the left here that it's an official image. And what an official image is that goes through the process that we have here at Docker to vet an image that is done with best practices in mind, that it's secure, and it's something that you should feel very confident about using. Right now in the news, there's a lot of talk about software supply chain attacks, right? And we're going to be talking about that coming here real soon in the next couple weeks. But the idea is you should really know where you're getting your software from, right? The internet is the wild, wild west, still is, right? And so pulling random software off the internet and just running on your computer is no bueno, right? You would not do that. My parents do that, right? Download software off the internet and run it. Oh yeah, hey, let me try this. Let me run it. Don't do that. We shouldn't do that as engineers either. So go to a good reputable place such as Docker Hub. Use the official images, the verified publishers program. So those are ISVs that we verify that they are publishing those images onto Hub, and they are who they say they are. So IBM, Red Hat, NGINX, those type of things. These are the verified publishers or official images, right? So you can see Docker. So node, it's the Docker official image. And I'm not going to go through all this, but let me scroll down a little bit. So after we pass the top, and I'm going to come back and talk about that. But it tells you what this image is. It tells you how to use it. It talks about the variants here. Not all readmes on all images do the same thing, but the node images does pretty well of explaining to you what each one of these tags are and what they mean. So I'll leave it up to the viewer to go and check this out, and you can read through it. But basically, you have node, which is the name of the image, and then you have a tagging system, right? And you can see here that node is talking about they usually put the version, and then you'll have a dash and then some kind of a name, right? These names are referring to usually the base operating system that image is built on top of. So as we scroll back up and look at a list of images, tags, also too, you can come over to the tags here and go down through and see what tags there are, and you can dive a little bit deeper into the details, but staying on the description. So how do I know what tag to use, right? Well, if you already know what the LTS, the long-term supported version of Node is, you can find that, right? See if there's an image built for that right here. Or what I typically do a lot of times is I come over to nodejs.org, and you can see it right here. So 14.17.3 LTS, long-term support. There is a 16.5.0 current, right? You could use this image also. I like to use the LTS as I'm doing demos just because it's supported, and it's pretty reliable. So we're going to use 14.17.3. So let's come back over to Node. I'm going to do a little search. So 14.17.3. So it's big enough. Apologies if it isn't. Let me scroll up. Okay. So here we can see we have 14.17.3-Alpine 3.11. So this -Alpine is telling you that we're running Node 14.17.3 on the Alpine distribution, which is a very slim distribution of a Linux OS. Here's a 3.1 version of the Alpine, 3.11, sorry, 3.12, 13, 14. And here's Buster. So Buster is the code name for an Ubuntu distribution of Linux or Linux. We also have Buster Slim, which is an Ubuntu slimmed down version of that OS, right? But we're going to stay safe. We're going to use the Ubuntu version of 14.17.3. So 14.17.3-Buster. So that's what I'm going to use when we build as our base image. So I have 14.17.3. Let's go to Buster. And this is very nice. Let me show this real quick. So VS Code will give you some type of heads, right? So I can see it right here. Okay. So again, just to review real quick. So the from command. Now, the from command allows us to do a little bit of object-oriented programming style. It's not exact for sure, but it's a good analogy. So we're going to take a base image called node, 14.17.3-buster. And then we're going to build our image on top of that. We're going to put our source code in there. We're going to build it and do all those things, right? But instead of us having to add all the support, actually install Node into the image, get it configured correctly, we have a base image that's already done that. So let's just use that. And then let's put the bits into our image that we need, right? Separation of concerns, basically. Okay. Yeah, Raphael, Alpine /node. That's a good one too, right? There's a bunch of really good images. We could probably spend a whole hour on unpacking a little bit more on how to think about your base images. But really what it comes down is it depends on what your need is for that image, right? Okay. So the next thing we want to do is we're going to set up a working directory. So a working directory, this working directory command basically tells the Docker engine, every other command that follows after this, create a directory called /code. And this name here is arbitrary. So this could be web, this could be source, it could be anything you want. It could be foo. Right? I like to call it code. Some people call it workspace. Some people call it web, app, whatever you feel most comfortable with. Use the name you do. I would say try and keep it consistent across. If you're in a microservices world, right, try and keep it consistent so that everybody knows your source code, your working directory inside that image is going to be named the same. So if you get an image that's running and you exec into that image, you know where to look. Okay. So the working directory will create a directory called code in this case, and then we'll move us into that working directory, and all files below that will be relative to the working directory. Not all files, all commands you run subsequently after the working directory will operate within that working directory. Okay, this is the same thing if you were working locally. You would create probably create a folder or directory in your projects folder, right, where you keep all your source code. You would CD into it, and then you would pull the code down, right, with a GitHub clone, something like that, right? And so that's kind of what we're going to do here. We need to get our code inside of our image. So the first thing we need to do is we're going to copy in our package.json files and our lock file. And the reason I'm copying these in individually is because of caching and the way the Docker engine works. And I'm going to come back to that after we build this, and we'll talk about caching and the certain order that I put these commands in. I don't want to muddy the waters right now. So just think of it as you CD'd into a working directory, you clone the application, and now you have your files there. We're doing a very similar thing, a little bit out of order, but the exact same idea, right? So now we copied our package.json into our working directory code, package.json. And actually, we could take this off because we set our working directory up here. So copy package.json from my local machine into the image in the working directory of code and call it package.json. And then the same thing here, we're going to copy in our lock file. Okay. And now we want to install our npm packages. So we're going to use the command, and we're going to npm, if I could type, npm install. Just like you would normally on a command line, right? I do npm install. There we go. It's going to go out. It's going to pull down all the packages. It's going to install them, update them, all those good things, right? Okay, so that's what we did there. Next thing we need to get into our, and the command does exactly that. It runs a command. Oh, this should be run. We're going to use the run command. The command we're going to use a little bit later. It's different. So the run Docker engine command will execute a process inside of your image, and the result will stay inside of your image. So we're going to run npm install inside the image. It's going to look at the package.json inside of our image in the package lock, and it's going to use those and install all of our node modules inside of our image. Exactly how you would do if you're working locally. Git clone, npm install is usually what you do first, right? If you're using Node or front-end app like React, Vue, Angular. Okay, so now we have all of our Node packages installed. Let's get our source code into the image, right? So we're going to do another copy command. And I'm going to take everything in my local directory and copy it into the working directory. Okay. So I'm going to take all my files that I have over here, and I'm going to copy them into my image. Okay. And then what do you normally do after that? So you get clone, you grab everything, you run npm install. You don't need to copy anything locally because that's what the get clone did. You're gonna start your application. You're gonna do an npm start. So we're gonna use a command called command cmd. What the command is, this doesn't get executed as you're building the image. This tells the Docker engine what command I want to run when you run this image inside of a container, right? And we're going to use the JSON structure here. I won't go into it why I use this. It's just cleaner. You can read in our documentation why best practices around using the JSON array format. So Docker run start. I'm going to be explicit and call Docker run npm run. Pardon me, just so npm knows and doesn't get confused. Okay, so let's save that. Right now, that's our Docker file. Should be very simple. Everybody should kind of understand what's going on here. Let's just review real quick before I actually build our image. Let me save. So you're going to start off with a base image. We're using Node 14.17.3-Buster. We took a look at Hub and we grabbed the official image. The first part of this tag is the version of Node. That's the LTS. I got the LTS from nodejs.org's website. And then the -buster is telling us that this image is built on top of Ubuntu Buster. Buster is a code name of a release of Ubuntu. Okay. Then I set up my working directory. I basically do a make directory code and then a CD into code, right? And then I'm going to copy package JSON from my local machine into the image. And then I'm going to do the same for my package-lock.json file. And then I'm going to run npm install, get all my packages installed, and make sure my source code is inside of my image. And then I'm going to say, hey, Docker, when you start this image, this is the command I want you to run, npm run start. Okay. If you have any questions, drop them in the chat, but let's go ahead and give this a shot. So the next thing we need to do is let's clear our screen. We need to build this image. So the way you build an image is you do a Docker build. I'm going to give it a -t, which tells it to tag the image, give the image a name. And we're not going to call it prod, but we're going to call it dev. So React-Docker : and then I'm going to give it a tag of 1.0.0-dev. I'm following that Node.js kind of tagging system. And then after you do that, then you need to tell it, what's your context? So for the Docker build command, you give it a context, and that tells Docker when you tell it to run commands such as this, take everything in my current directory and move it into the image inside of this. You're telling Docker with the context, you tell it, this is where I'm working. You should execute this Docker file within this context, within this folder, so to speak, right? And you can change the context. So I can have this Docker file in one folder, and when I do my my Docker build, I could say something like that and say source, right? And it'll go up one directory, it'll look in source and use that as a context, right? Your Docker file might be in a different location. But that's what this dot is doing. So again, I'm doing a Docker build command. I'm doing a -t for tag the image, name the image, and I'm naming it React-Docker : 1.0.0-dev. Okay. So I'm gonna hit enter. It's gonna go ahead and build the image, and it's basically running those steps that I have in that Docker file. You can see right here. So 1 of 6 from Docker. So it's using the Buster image. 2 of 6. It's going to create the working directory. It's going to copy my package JSON files in, my log file in. It ran npm install, copied all the files in. It's saying, let me export what I just did into an image. And to do that, it exports the layers, writes the image here, and then it names it, right? So now we could do Docker images and take a look. So here's the image we just built 25 seconds ago, right? Let's Now, the next thing you want to do is we're going to run that file, and we're going to run that image inside of a container and make sure everything worked, make sure our application is still running. So to do that, we're going to do a Docker run. We're going to give it a dash. You can see I've typed it out here already. So def. So let me go through the commands, the switches here. So Docker run -- rm means remove. So when you automatically remove it when you stop this container. So when we do either Control C or we do a Docker stop, when that container is stopped, if you started it with the -- rm, it will also remove it. So the couple statuses when you run a container, it could be started, it could be stopped. You can restart a container, those type of things. So when you stop it, it doesn't go away. It basically pauses that process, and you can restart that process. You have to remove it to actually remove that process, unless you started with the -- rm. Okay, then we give it a -it, which is an interactive terminal. And then we do -- name. So I name my container, do a -p, which publishes a port. So this is actually going to be 3000. So if you're familiar with Create React App, it default runs on port 3000. I didn't change that anywhere. We could probably jump into the source real quick. Find I don't think it's. Oh, forgive me. This is the React app. Sets up a dev server, and that default port is on 3000. Later on, you're going to see when I add in an NGINX how we set the port. So the default dev server for Create React App runs on port 3000. So we're going to expose or publish port 3000 on our local machine 3000, and we're going to map that into port 3000 inside of the container. If you remember earlier when I was talking about images and containers, so we have this image that has all of our files in it. That's what we did with our build. And then when we run it, it's going to run inside of a container, but that process is isolated, and it's isolated from the network by default. So we basically have to give it a firewall rule. We're going to say publish port 3000 and direct traffic from on the local machine port 3000 into my container on port 3000. So that's what I'm doing here with the -p. And then I give it the name of the image that I want to run. So React-Docker : 1.0.0.0 -dev. And that name should be very familiar. That's the name that we gave our image in the previous step. Okay, so let me hit enter. Let's run our image. You can see it's very similar. We've seen that before when I was just running on the command line. We started with compiled successful, running on localhost 3000. So let's take a look here. So that is port 3000. We're still running nice and fast there. Okay, let's make sure the app still works. Let's give it a name. Let's create a record. Name, foo. Let's save that. Cancel that out so we can see it. Okay, it's working. Things are great. Let's clear this out and go submit. We should get the, yep. Okay, functioning great. We can see right here that things have been look totally normal as a Create React app, just the same thing as we did in my terminal. But everything now is inside of that image that we created. So you can see right here on my terminal. Let me go into another terminal and let me bump that up nice and big for everybody. It looks about the same. Let me do that. Okay, cool. So now we can do a Docker PS. And what Docker PS is basically telling me what's running, what containers are running on my system. And you can see I have a container ID. The image name is that image we looked at. Here's the command that was run. Here's the entry point. I'm not going to talk about entry points right now, but you basically have entry points and then commands. An entry point is usually the default place where the default command that will get executed for your image when it's run inside of a container. And then it tells us created a minute ago, status is up and running, and then it tells us what ports are being mapped. So you can see 3000 on local is being mapped inside of my container. And then it tells you the name, web. Okay, so we have the image running. We can execute a command inside that container, and we're going to execute. We're going to give it a IT. We're going to tell it what container we want to execute, and then we're going to, I think we have bash. Let's give it a command. Whoops, you got to spell Docker, right? I can't type. There we go. So now we're inside of that container. What happened here is it created another process inside of that container that's able to see everything that's running in that container that's isolated inside of there. So you can see it directly put me into /code. So if we do an ls, list our directory ls-l, a little bit easier to see. You can see I have a Docker file in there. I have a README, I have node modules, package, public, source. Okay, excellent. So let's exit out of there and we're clear. Come back. Now, normally, what did we do last time? We fired it up normal on our terminal. Then we went and made a change and we saw the change happen. So let's do that. Let's test that out. So we come back over to my application. That might be a little big. There we go. Okay, let's find, there's the submit button again. Let's change it again to go before I'll save. Let's just come over. Still says submit. Still says submit. Okay, I have go. You can see that it needs to be saved. I'm going to save it. Now it's saved. Let's come back. Uh-oh, it's not updating. What's going on? Well, what's happening, I set you up, of course. So what's happening is when we were running locally, all of our files were local. We ran that npm start. It did some magic where it Babelfied your code and that it puts a little dev server and serves it up. It watches your files. Anytime you change, it updates, right? Well, now we have everything isolated and running inside of a container. We're able to see it because we exposed port 3000. That's how I'm able to see it. But this file I just edited is not inside of that container, that running container. It's outside of it, right? So we got to figure out a way is how do we edit the files inside of my container so I can develop inside of that container? One of the ways you do that, one of the easiest ways you do that, let's come back over here. Let's stop our container from running. We'll jump back over here. We'll do a docker ps. I can't spell Docker today. Okay, and we see that remember we did Docker PS before. We could see our container running. Since we hit Control-C on the command line here, that stopped the container. Again, if you remember, I did a --rm. So when it stopped, it removed it. So we don't have a container just paused out there. All right. So now we got to figure out a way. How do we edit the files inside of our container so we can make changes and we could see them updated on the screen? So let's do that. One of the best ways to do that is to use bind mounts. So I'm going to do a docker run. And this is the command we just ran before. But this time, I'm going to give it another flag, a -v for volume. I'm going to give it my working directory. So pwd. So if you do a pwd here, that gives you the print working directories. I believe that's what that stands for, pwd. Return working directory name. Okay, I use p as print working directory name. Anyways, so that's what that's going to do. It's going to print out. So we are currently in Docker examples Acme, right? So that's what, when we run a pwd, let's just do that now. So if I run a pwd, you can see it gives me the full name, directory name of where I'm at for path to the directory name. So users Peter, Docker examples Acme. So that is what this will equate to when we run that command. Where did my Docker run go? So Docker run. So let's give it a -v, pwd, colon. So we're going to say take this local directory on my local machine and map that inside of the container. So I'm going to map it into code because that's our working directory. That's where our source code is at. It's going to map that into that image. The Docker run command is exactly the same. Now we added the bind mount flag. So let's hit enter. So we're going to start up again. Again, looks very similar. It's just as we ran it locally. Just reading some commands here. Yes, the recording will be available. It'll stay on YouTube. It'll live in perpetuity. Let's put it that way. And yep, so it'll be available later. Naveem, let me know. You might have asked this. So I might have answered this. If I didn't answer this, let me know again. I can go back over what command is. Why don't I just go back over it again really quick? So the CMD, so we take a look at our Docker file. So if you remember here, when I did the run command, that runs whatever command comes after it when we're building the image. Okay. The command will get executed when you run your command, not at build time. So not when we did a Docker build. That's when line 8 will get run when we do a Docker build. When we do a Docker run is when the command will get run. So the command, I got to think of a better way to explain that. But the command tells the engine, hey, don't run this when you build, but when you run my image inside of a container, the process that I want you to start, use this command to start that process. So the command tells the Docker engine what process to start and how to start it. Let me know if that doesn't make sense. Do we need to expose port 80 in Dockerfile, or it takes by default? I always expose it when I run it. You could put an expose here. Like it type. So expose 80. You could do it in here. I explicitly expose them when I run the command line. Okay, please explain --rm again. Yeah, so let's jump over here. Let me go here, clear. So Docker run, and let me do it --help. And let me move my microphone out of the way. Sorry for the fast scrolling. I'm trying to find the RM. It should be alphabetical. There it is. So RM. So automatically removes the container when it exits. So let's see. Let's do this. So let's do Docker run --it in the background. Don't worry about that for right now. I think we go busy box. Only one dash. There we go. So that's going to pull down busy box and it's going to run it. So let's do a Docker PS. Okay, so you can see we have busy box running, and you see the status here. It's up 2 seconds ago. So let's stop busy box. It's optimistic cyanosi. Let me grab that name. You can actually use the container ID. So let me do that. So I'm going to do a Docker stop. Should stop the busy box. Oh, come on. Don't mess up my example here. There we go. Okay. So now let me do a Docker PS again. You can see it's not in the list, but now if I do a Docker, let me take this off the screen. Make it clear so it's easier to see. So now we do Docker PS. It's not there. We'll do a Docker PS -a that says, give me everything. Show me everything that was running. Let me grab this name. Okay. So you can see it exited, right? 17 seconds ago. So let's try and run it again. So we do Docker run, busy box. I'm going to give it a name. The same name, if I can type, same name as before. And it says, look, there's an error response from the daemon. That's the Docker engine saying, hey, you have a conflict. You already have a container running that's named that. But you might say, this happens a lot. People ask me this all the time. You do a Docker PS and you're like, well, I don't see it running. What are you talking about, right? That's where you need to do, so you all can see, that's where you need to do a Docker PS -a that shows you everything and say, oh, there it is, right? So we stopped it already. Remember, I did a Docker stop, but now I'm going to do a Docker remove and give it the name. No. So now if I do a Docker PS -a, you can see it's gone. If I do a Docker PS, right? Now if we try and start that Docker, that busybox image, enter again, let's see, with that same name that we've been using, and there it goes. It'll start back up, or not start back up. It'll start the image again, a new image inside a new container. Sorry, image and container, sometimes they're interchangeable, but they're not the same, right? So it's starting a new container. You can see it running. So we'll do the same thing. What I do a lot of times is I do just rm-f And then let's grab the name, copy it. So a little shortcut, instead of stopping an image, then removing it, you can do an RM. If you don't push the put the dash F flag, which means force, it's going to tell you, hey, I can't remove it. It's still running. The dash F will stop it first, then remove it. So we'll do that. And now if we do a docker ps-a, it should be gone. Okay. Hopefully it answered the dash RM question. Yes, we are, Herbert. We're going to do multi-stage here in a second. Okay. So we built our image. Where were we? Do we update that code yet? Take a look. Sure, what I changed there. Nothing like doing live demos. Let's see where we're at. Okay, well, I got my code changed. It's saved. Oh, that's right. I stopped my image and I mapped in the volume. Let's do it again just so I could show everybody. So if you remember when I first ran this, not BusyBox. Oh my goodness, can't type. BusyBox. So there we go. Okay. So the first time I did it, I didn't map in a volume, right? I didn't bound mount a volume into the container. So when we changed the file, the server updated. It said, oh yeah, there you go. It's still running, but it didn't see a file change because the file we changed lives outside of that container, right? So now what we're going to do is map that in. PWD for the print working directory, and then we're going to map it into code. Enter. I'm going to start back up. Wait for it. Come on, React dev server. There we go. And we're going to see some magic happen here. Not real magic, but give it a second. It's still spinning up. There we go. And you can see it's been changed. What happened there, right? We didn't copy anything in, but we did the bind mount and mount my local files into that image, and it picks up the change. So now we're running, we're live, we're still running. Let me go back to the source code. Let's change this back, right? Let me save it. We come back to, and there we go. It's been saved. It's been updated, pardon me. So 1, 2, save. Let's see if I can alt tab quick enough. There it goes. Now I got 1, 2, right? So now we're running inside of a container. Our application is running inside of a container. It's watching our files. Our files, local files have been, source code has been mapped inside of that container. We're changing files outside of it, but they're being synced up inside the container, and we can see our changes right inside the container. You can even debug. So when you hit this 1, 2 button, you can see it says, please enter an entity name. Let's see if we can find that source code. So I'm just in, the debugger, the browser debugger, the Chrome tools. So open up source. I'm going to go into app.js. I know this is the handle submit of this 1, 2 button. So I'm going to put a breakpoint right here. Come back in, click it. Fantastic. So we are now running our application in a dev mode inside of a container, and we're debugging right in our dev tools in the browser, and we're able to change source code right in a VS Code, right? In reality, theory and reality, you could have had a brand new machine with Git installed and Docker and VS Code. The only thing, 3 things you need. You don't even need VS Code. There's no magic. We're not using VS Code. We can use a text editor. You can use a VI Emacs that come with your machine. So we basically installed Git, which probably comes with your machine nowadays. So we got Git, and you install a Docker engine. We cloned the repo, right? We run the Docker file. We run the Docker file, build our image. We run that image inside of a container. We map our local source code into that container, and we're off and running and developing. That means you can have that Docker file. Let's say you have a couple different front ends that are running a couple different versions of your tools, right? And you don't have to install it all locally. It's all inside of that container. Okay, you can debug, do everything. Let's stop the debugger. Let's keep going. All right. So that's pretty cool. Let me jump out the questions. Herbert's waiting. We're getting there, brother. We're getting there. Okay. So awesome. So the next thing I wanted to talk about real quickly is how you run. Yeah. So the way we did this, right? So if we let's take it back. Let's take a look at our Docker file, right? So this is all fine and dandy, but we don't want to run a couple things wrong here, though. We don't want to run npm when we're running our container in production, right? We just want to run actually with the React and Vue and Angular and raw HTML and JavaScript. Nothing's getting processed on the server. Nothing's getting executed, as opposed to like Node.js. That JavaScript is getting executed on the server, right? But with React and all of our front-end tools, they're front-end, so they get executed in the browser, right? So all we need is a wicked fast web server to get those files from a server and get them down to the client as fast as possible, right? And we don't want to run npm. We don't need it, right? We do need to Babelify our JavaScript, right? Our React application and get it all minified and all packaged up nice and neat, put it all into one file and serve up that one file. Okay, so let's take a look at doing that. And this is where we're going to start talking about multi-stage builds. Let me pull up my sample so I don't have to remember my whole Docker file from scratch. Okay, so okay, so two things we need to do, right? We need to run npm to get all of our node modules and put into that image. And then we got to run that build process, right? To take everything and package it all up. Okay, so that's one step. That's our build step with a React application, right? So we're going to create a build step in a multi-stage. So we're going to create a build stage. So I'm going to call this build. The way you create different stages in your multi-stage Docker file is you label them at the from command. So I'm saying take from the node, we talked about that, and label it as build, right? So now I'm kind of labeling all these commands as build, right? I'm still going to set up my working directory. I'm going to copy in my package.json files because I'm going to need those to install node packages, but I'm not going to do an npm install. I'm going to do an npm CI -- production. There's different ways you can do this. I won't go into the whole bunch of best practices, but you might remove cache, you might remove different things, right? There's some streamlined ways you can run this, but npm CI -- production is pretty darn good. Okay, so we're going to do that. We're going to load, install of our npm packages for production, right? We're going to copy our local source files into the image. But instead of running, instead of telling it what command to start inside that image, we're just going to get rid of this. No, we're not. We're going to run, excuse me. We're going to change this to a run command, and we're going to do npm run build, right? And I assume most of you on here probably watching are at least know npm or React folks, but let me just show what it's doing. So if you go into package.json, you have a script section. These should be very familiar if you're doing a create React app. If not, you probably have modified these somehow. Your application's done, your development team has added scripts in here or not. The way they do, the way your team runs things, but they're going to be very, very similar. So we have a React scripts build. And basically what React scripts build does is goes out, looks at all your source file, minifies it, packages it all up into one file, puts it into a build directory, takes all your CSS and puts it in one file, creates an HTML that references those two files, right? And now we'll have an index, a JavaScript, and a CSS file. And then we can use those and just serve those up from a web server, okay? So we're running npm CI production, make production builds. And then we're going to run npm build, take all those files, put them all together, and do all the things I just said. Awesome. If we just built this image now, it would run. It'd be great. And we would just have an image. And we'd run that image inside of a container, and it would do nothing, right? Because we didn't give it a command. Actually, what it would do is drop you into the node REPL. That's the default process that gets run when you don't tell it what to run. And that comes from the base image. Okay. So that's our stage. That's our build stage. That takes all our code files, source files, packages them all up, builds them, packages them all up, and they're ready to go. Okay. So now we're going to add a second stage in there. It's going to be our NGINX server. So I'm going to copy this in just so I don't have to type it all out for folks here. So same thing. We create another stage. We call it as prod. So we're going to call it prod, right? And we're using NGINX version 1.12-Alpine. So the dash Alpine is the Alpine distribution that NGINX is put on top of. Alpine's a very slim, small distribution, Linux distribution. Okay, and then we do, these commands should be very familiar now. We do a command, a copy. Here's a new flag though. We're going to do a -- from. So what the -- from tells the copy command, don't look locally, but look at this other stage here, build. And as you can see, it's labeled up here in build. So it'll go look in this temporary image for the files for the copy. So it's going to say copy from build up here, encode build, take all of those files and put them into this new image that I'm creating and put them in user share NGINX HTML. If you used NGINX before, this is the default location for where NGINX serves up files, static files. Okay. So we do a second phase. We say, I'm going to create this image based on NGINX. I'm going to copy the files from the earlier stage where I built everything, copy those into this image, and then just have NGINX. So we don't have Node running in this NGINX. We don't have any other support files that might have been in the Node, right? No text editors, those type of things, just NGINX, right? And then we expose port 80, and then we tell it a command. When you run this image inside of a container, this command right here on line 21, that is the command that starts the process inside of your container. So we're going to go NGINX -G. I actually forget what the -G is. It's going to tell it daemon off, right? And so it's going to run up it's going to use the default configuration that's set up in the NGINX server. It's going to look into user share NGINX HTML for the files it needs to serve. And it's going to serve those up. So let's save that. Wow. Well, thank you. Thank you, Herbert. It said the real-time debugging inside a container. It's magnificent. Thank you very much. Awesome. Okay, so here's a good question. Let me pull it up. Do you need to copy source code into the image since you map the source directory to code? Oh, earlier when we yeah, so let me copy this real quick and then let me undo everything back to the way we had it. Oh, you know, no. Yeah, so sorry. Let me delete that out of here. We had a command here, but you're talking about this this command right here in our Docker file, the copy, right? So what Richard is asking, hey, is that second time you ran it, you mapped the volume inside of the container, which had your source code locally, and now it's inside the container. Did you have to actually manually copy everything in the Docker file when you originally built the image? You don't. It depends. It depends on how you want to do it, right? I like to still copy it in because if someone else is using this and they don't mount their volume into the container, then they won't have any source code and nothing will work. Everything will be broke, and then they're gonna slack you and say, "Hey, your image doesn't work. You're horrible. We should fire you." No, I don't think they'll fire you yet, right? So, yes, technically, Richard, we wouldn't have to. We could comment this out, and we could build the image, and then we map in our source code, and it would be there, and everything would have worked fine. Yes. I'd like to copy it in case, like I said before, if you take this image, it's going to have the source code in case you forget to bind mount. Great question. Okay, let's see. Excellent. There we go. Okay. So there we go. So now we have a two-stage Docker file. First stage comes right here, and it's labeled build. And I'm doing all the things we did before. We modified the NPM, so we're going to do a production build. And then we're going to run right away while we're build this. We're going to run an NPM build. So it's going to take all those files, minify them, do all the magic that create React app does, puts it into a build directory. You have one index.html file, right? Just for fun, let's just npm run build. let's build. Let's let that build for a second. Okay, so that was the first phase, right? Second phase, stage, says, okay, create me an image. Use the NGINX 1.12-Alpine base image, label it as prod. Copy the files from code build into user share NGINX HTML. But oh, don't do it normally. I gave you a flag -- from, and I gave you the stage build. So copy it from here. That image we just did are nice productionalized files. Copy those from code build into my NGINX container. Forget about everything else. Leave that all out there. Leave the package JSON, leave the source files, all that stuff. Leave it out of there. Only copy the files that were built that now live in my build directory. And now that I ran it locally, you can see what gets copied in, right? So you get a manifest, the index.html, nice and minified, does some JavaScript magic here where it checks prototype has owner and all kinds of stuff, right? Does some magic to get your code actually down to the browser. So you have a manifest, the asset manifest. You can read, you can go through, here's the robots, service workers, React.js, create React app sets up a service worker for you. Not sure I like that, but anyways. Okay, and then you have in your static file, here's our JS. Here's all of our, did I hit the map? I hit the source map. So there's your JavaScript all nice and minified and obfuscated. I can never say that word correctly. So it's obfuscated, which basically means take all the normal names I have in my variables and name them A, B, C, T, E, N. So it makes reading the code very difficult, but you can still read it. Okay, so now you know what gets what's actually in the build, the output of this this output of the npm run build, what actually gets outputted. That's all these files. And then you'll see a CSS. I always hit the map for us. So here's all the CSS that it took through the application, put it all together. Okay, awesome. Sorry if I'm talking fast there, but don't want to spend too much time on it. Takes all those files, puts them into user share NGINX HTML, exposes port 80, and then says, hey, NGINX start up and serve these files. Awesome. So cancel. So let's save this. Let's build our image and then let's run it. So come back to the terminal. So we have Docker images right now. You can see we have our React Docker 1.0.0-dev, right? And so now, and you'll see it's 1.25 gigabytes. Now I didn't have a Docker ignore file. We're going to come back to that if we don't run out of time. But so now I'm going to do a Docker build again. I'm going to give it a -t, and I'm going to call it React-Docker again, :1.0.0 - let's just call it prod. And I'm going to give it the local context. Again, the context tells the Docker engine where you want me to do the work, where you want the engine to do the work, right? And so I'll give it a dash. If your Docker file is not in there, in your context, and if it's not named just Docker file, then you'll need to do a -- file and tell it where your Docker file is to use. Okay, so let's run this build. Okay, going to do the same things before. It's going to go down through the top. It's going to start executing everything. And here we go. So we're on 6 or 7, copying everything in. It's running npm build. So here it goes, is creating optimize. Let's get this off the screen so y'all can see that. Let's do this maybe a little bit easier. Let me know if the font isn't that great. I can bump it up. All right. Thanks, everybody. It's only cool to us nerds. I always say nerd, to us geeks. But yeah, it is cool. Thank you. I appreciate it. So let me make that a little bit bigger so you can see. Okay, awesome. So we just built our image. Let's go to the top here. I'm going to do a Docker images. If I can type again. So there we're listing out our images. Here's dev that we built a little while ago, 34 minutes ago. And here's the prod, right? And now you can see this image size is only 16 megabytes, right? Why is it so small? Because we did that multi-stage. We said, oh, do all the heavy lifting up here. Go ahead and build everything, compile it, minify it, obfuscate it, do tree shaking, right? All the code that's not being execute pass, right? Get rid of all of it. We don't need it, right? Only give me what I need. Give me the output. everything that's in this build file, this build folder, excuse me, right? And then start a new phase. I'm going to use a new base image, the NGINX based on the Alpine, which is a very slim image size. Copy everything from the build phase above it. Copy that into user share nginx.html, expose port 80, and then run nginx. That's how you got a very, very small image. And that's why I wasn't worried about doing a Docker ignore earlier and all those type of things. You absolutely should do a Docker ignore, but I didn't want to get sidetracked on that. So you can see here's our dev image is 1.125 gigabytes. And right here, about 17 megs. So huge difference, nice small image. Okay, that's awesome. We got it built, but you know, who cares unless it actually works? So let's run it. So I'm gonna do a Docker run. I'm gonna use all the same things, but I'm gonna get rid of mapping in our source code. We don't need that. Okay, let me run through these flags again so everybody understands. So I'm doing a Docker run. That's the command we're running. We're gonna run an image inside of a container. That's what you're doing when you're running. That's the difference between an image and a container. And an image is a template, is a template, is set up, packaged up. It has everything in it. It's ready to go. And then when you run it in a container, it's an instance of that image running inside the container. Just like an object-oriented program, you have a class, which is your image. So you have a class, and then you have an object, which is your container. Your objects is an instance of that class. So you can have multiple objects of that same class. So we got a user class. We go new user, you know, var Joe equals new user, var Peter equals new user, var Sally equals new user, right? Those are all instances of that class all running. Same thing with Docker. You have an image. When we do a Docker run, that creates a container based on that image. And we could do this multiple times. So you can run multiple instances of that image inside of containers. And that's how you scale, and that's how you do orchestration. That's what Kubernetes does, Swarm does, you know, all those orchestrators do. Okay, awesome. So we're going to do Docker run. So take that image, run inside of a container. We're going to give it a --r. It's a nice convenience when you stop your image running locally. I want it to go away. I don't want to do a Docker stop, Docker remove. Okay, and then we give it an IT. I give it an interactive terminal. We're going to name it web. We're going to expose. We're going to publish port 3000. And we want to map that to port 80. NGINX inside that container is running on port 80. We can change that. You could change the configuration, the NGINX configuration, whatever you need to do. But remember, it's isolated inside of that container on its own network, right? So it can access port 80, not the same port 80 that's running on my machine. So I want to map publish port 80 on 3000 on my local machine. And I'm going to map that back in. All right. So we'll be able to access this NGINX server using port 3000 in my local browser. And then I tell it what image to use. So React-Docker 1.0.0-prod, the one we just built. And if the demo gods are with us today, everything should work just nifty. So I hit enter. I don't have anything back. Okay, let's test this out. Let me answer something referring as prod in the second stage, technically needed. No, Harish, it's not. It's not technically needed. So what Harish is saying is down here where when I said this is prod, do you have to name the last stage inside of your Docker file? Do you have to give it a name? No. It's gonna run if you don't give it a target. So when you do a Docker build, you can give it a target of what stage to use, and these are hierarchical. So if I had other, you know, from let's just do node as you know, local or as dev, right? And I copied everything, you know. You could add multiple things here, right? So I can have another command here. So this is a stage. Sorry, this is a stage, right? This is a stage, and one up here is a stage. So when you do a Docker build, you can give it what target to build. And if I gave it, let me get this out of the way so it doesn't confuse folks. Okay, so if I did a Docker build and I said --target and I said prod, what the engine will do, what build X actually does, looks at Well, the Docker engine does this too. So it'll look at prod and it goes, okay, what dependencies does it have? It has build. Okay, so I got to run build first. So it'll run build and then it'll run prod. But since this is the last one in the Docker file and you don't give it a target, that's the target that's the default target, right? So yes, we technically could have left that off there. I like to label it because usually as you build these out, you're going to have a build phase stage. You're going to have a dev stage so that the original Docker file that we built, you could use that as dev, right? So you can do Docker build target dev and run that image locally, right? You technically probably, could leave the production as the default. So anytime anybody builds this out, builds it normally, it will be built as a production image, right? That kind of should be your default. And then developers locally should build specifically with the dev target, right? Great question. Okay. A good question here. So I've heard that the backend knowledge helps a lot in Docker and DevOps stuff. Does it? Is it true? And if yes, which language you prefer to learn from? It doesn't directly help, in my opinion, other than in developers, engineers, software engineers that are working in the backend. They do have to deal a little bit more with operations stuff, right? DevOps, they deal a little more with servers, those type of things, right? And therefore that kind of leads into Docker. They're building images a little bit more, right? So that's probably why they just have a little bit more body of knowledge that applies to containers and images and Dockers, right? As where front end, you might not need to do all those things just to build a Vue.js or React.js, right? But they're not directly tied. So you could do a ton of stuff as just a front-end dev, mostly in React. You don't need to learn a middle-tier back-end type of language. So no would be my answer. I think it's just because more back-end folks are dealing with servers, right? Their code runs on a server, right? That type of thing. What language would I think if you're thinking about back-end? If you're a front-end developer, start with JavaScript. Stay in JavaScript, go to Node.js, right? Learn it there, learn how to build APIs, REST APIs, how to talk to databases, get really good at, generally speaking, as a software engineer, the two things that you should focus on to progress as a software engineer is coupling and cohesion, right? So you want your code to be loosely coupled, but highly cohesive. I don't want to go into it right now because we're about an hour and 15 minutes, but maybe I should do a whole show on that. But that's the two secrets outside of, and those two things apply to procedural languages, functional languages, object-oriented languages. They all are based on clean code, which is based on cohesiveness and coupling. You want your things loosely coupled and highly cohesive. So cohesive means if I have a log writing module, that log writer should only know how to be able to take logs and write them to a file. And you can even split that out farther and say, all what a log module should know about is how to grab logs at a different levels, let's say errors, warnings, those type of things. And then it should depend on something else, or not depend on, but should use something else that knows how to write to a file, knows how to write to a database, right? And those should be loosely coupled. But inside of that logging module, it should know everything about logging and really nothing else, right? So it's cohesive to what it's trying to do. Separation concerns you probably heard about, right? And they're loosely coupled. So I have my application that is loosely coupled with my logging mechanism, right? So I have my application. I can plug and play different logging modules. I could plug and play how they get written to disk or to a database or push to an API, right? So you want things that are loosely coupled and highly cohesive. Focus on those two. Don't worry about back end. Find a language that you can practice those in. JavaScript's fantastic. Second to that, I would think about Python and Java. JavaScript, Python, and Java is the top three languages I see out there in the wild. Not just myself, but people that do, that actually talk to massive amounts of developers. Okay, awesome question, guys. I really appreciate it. So we ran this. Did we not? Did we run this? I don't know. I can't remember. Yes, we did. Oh, we started it up. So we ran Docker run. We gave it my infamous --rm IT interactive terminal. We named it as web, put it on port 3000 into 80. And then we told it what image to run. And we said, go for it, Docker, run this image inside of a container. Let's jump over this command line. Let's do a Docker PS. Whoop, PS. There we go. It's running. It was up 7 minutes ago. Wow, answer question for 7 minutes. I appreciate the questions. Oh, we're going to talk about, yes, we'll talk about cache layers in a second, but let me finish this up. Okay. So now we did our multi-stage build. We produced an image that only has NGINX and our HTML, CSS, and some other stuff that you guys saw in the build directory. So let's go back to our browser. Let's do 3001 so we get a nice blank screen. So let me go to port 3000. And there we go. Ready like a champ. And there you go. You see all your NGINX logs. Boom, 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 boom. There we go. Everything is inside there. We got a production build. It has just our minified, obfuscated code inside of that image running inside of a container. Now you could pass this one around, and whoever your ops, DevOps, whoever you have, maybe even someone else on your team can run this in some kind of orchestrator. They can run it in ECS, ACI, EKS. You can run it on an EC2 instance with a Docker engine running. That is 1000% a good idea, right? If you're working at a smaller business, or doesn't matter the size of the business, if you build an application for a company that has 5 users in the accounting department that use your application, you do not need Kubernetes. You do not need Swarm, right? You don't need an orchestrator. You can set up a DigitalOcean compute instance, have Docker engine running on it, and run your container right there. Very simple. Before I came to Docker, we did that for all of our clients. Ran really, really great. All right. Here we go. One more question here. Datavir, I'm probably pronouncing that wrong. Forgive me. Hello, Peter. Any advantages of using NGINX server? We could write an Express app and say node server. Yeah, absolutely. What I like about using NGINX or, another web server is, separation of concerns again. NGINX is a fast, powerful web server that's been built to do just that, right? Serve static files extremely fast and can scale really well, right? So that's why I like to use it. But yeah, absolutely. We also did that for many years. I probably still have it laying around. I didn't use Express. I just wrote pure JavaScript, right? A little web server that, looked at the URL, read it off a disk and sent it back, right? So yeah, if you have a little Express app that handles serving up your files, absolutely, you could do that. I just think NGINX in a production environment, it was made and built to do just that, and has been tested by millions of instances running in the wild. So that's my thought around that. But there's nothing inherently wrong, yes, if you build a Express app or you have a web server that you really like, use it, right? Use it. Okay, awesome. So that's what I have for you guys today. I know we went over a lot. I hope you enjoyed it. Let me turn off my sharing here. Stay tuned. We're going to do a follow-up. I'm going to take, so we looked at a little bit of developing inside a container. We have some new features coming out called dev environments. They're in our product right now. They're in a dev preview. Go play around with them. I'm going to show you how you can use dev environments to do a little bit of what we just did. So you basically can point at a GitHub repo, pull it down. Everything will be inside of containers, and it actually wires up into your VS Code. So you can start coding, you can start debugging right away. And then you're able to take that dev image and share it with a coworker who can pull it down, see exactly where you're at in your code, your environment, your configuration, and maybe edit a PR, review a PR, make a change for you, share that environment back with you, and you could take a look at it. Stay tuned for that. We're going to have more content around that. Again, thank you everybody for joining me. I really, really appreciate it. Let me get my my CTAs I like to do at the end, so give you a little bit of help. But first of all, please connect with me on Twitter, reach out to me, tweet at me. Let me know you have any questions. Let me know what else you want to see on the show. If there's something that you want me to cover, if you want to go, if you want to do a Vue.js or an Angular, the concepts we went through are, exactly the same. We can do an advanced front end containerizing an application, right? You might have things, let's say configuration, right? Where I have my front end app and I need to know where to point to call my APIs. And that might be done in environment variables, configuration, those type of things. But again, at runtime on the server, your React app is not being processed to change configuration and then put it down, right? So anyways, let me know, tweet at me, follow me. Also to go out to join our developer community. The URL is right there. You can see what meetups we got going. I think we have a community all hands coming up. Check that out. And then also join our community Slack. I'm on there. A lot of our engineers are on there. Product folks are on there. You can interact with us. Our community is huge. It's very active on Slack. You can ask your questions. People in the community, captains are Docker captains, which are experts out in the field that are actually working at companies like you, day-to-day, hands-on with Docker. They help us out in Slack. They're fantastic. You can interact with them. And then also check out our roadmap on GitHub. You can see what we're working on. You can see what we have planned. You can see when things should be done. Create issues in there if you want to see a feature for Docker, Docker Desktop, Docker Hub. Put them in there. We do read them. We do interact with you. Great way to get involved with Docker and help direct the direction of the company. All right, everybody. Thank you so much. I really appreciate you joining. I hope you enjoyed it, and we'll see you next week. Take care.